Good morning, everybody. Here I have IAL past paper over here. So it's October 2024, regional paper. Here's the paper code, right? And it's pure to IAL mathematics, pure one. There are going to be 11 questions in this paper, right? So let's begin with the first question. A continuous curve has the equation y is equal to f of x. A table of values x and y for y is equal to f of x is shown below. Right, so they mean that here there are some table of values, right? Using the trapezium rule with the y values given, find an estimate of the integral of f of x. Now, whenever we have to use the trapezium rule, we have to first find the number of strips, right? So number of strips is going to be number of values minus 1, right? How many values are there? 1, 2, 3, 4, 5. 5 minus 1, and 5 minus 1 is 4. Alright, now we need to find the height. Alright, now the height is going to be b minus a over n, where n is number of strips and b is the upper limit minus the lower limit. So 5.5 minus 0.5 over 4. Right, when I do this, you should get 5 over 4. And now the trapezium rule is going to be half times by 5 over 4, the h value, times by add the first value and the second value, and plus 2 times by these values, right? So times by add the first value plus the second value plus 2 times by 6.101 plus 7.448 plus 6.823, right? A half times by 5 over 4. Now you have to put this into your calculator and let's see what the answer I get is. 3.878125, which is roughly equal to 30.9. By using the answer to the part A, making your method clear, estimate the integral of f of x plus 4 of x bracket. Yeah, so over here what we need to do is kind of split the integrals up. So here's our part A and here's our part B. Now the part B, what we can do is we can split the integrals, right, for f of x, right, in respective to f plus we can find the integral of 4 of x, right, for x in respective to x. So that's how we have to split it up. Now the integral, what I have found, is going to be 30.9. Yeah, you have to use that answer. I'm not sure, you can use either of them. 30.9 plus the integral of this. So definite integral is going to be 4x plus 1 plus 1 plus 1, and you divide and add the powers. So when you do that, you are going to get 30.9 plus, we are going to have 2x squared 5.5 0.5, and now 30.9 plus 2 times by 2 times 5.5 squared minus 2 times 0.5 squared. So 30.9 plus 2 times by 5.5 squared minus 2 times 0.5 squared. So you should get 90.9 as your final answer. So that's our first question done within 6 minutes. And sequence of number is defined: u1, u2 and u3, right? u1 is 7, un1 is going to be minus 1, and u times by un, okay, plus k. Show that u5 is 7. Okay, so now you have to find u2. Now u2 is now going to be u1 plus 1 is equal to minus 1, okay, to the power of 1, and this is going to be u1 plus k. Right, so this is going to be u2 minus 1 to the power of 1. Now u1 is 7 plus k. Now u2 is now going to be minus 1 times by 7 is going to be k minus 7. Now let's find u3. Now u3 is now just basically going to be u2 plus u plus 1 is going to be minus 1 to the power of 2, right? And yeah, 2, and we have u2 plus k. Now what we can do is here 1 minus 1 to the power of 2, and now u2 we have found is k minus 7 plus k is going to be 2 plus 1 is 3. Now since minus 1 squared is positive, so this is all going to be positive here, u3, yeah, this whole bracket is going to be positive as it is since it's 1. So this is going to be 2k minus 7 is u3. Now let's go for u4. Now u4 is basically it's going to be u3 plus 1 is going to be minus 1 to the power of 3 u3 plus k. So this is going to be u4 minus 1 to the power of 3 is just minus 1. u3 is going to be 2k minus 7. The previous answer, basically over here you just keep subbing in the whole answer here. Similarly you have done for u2 and u1s before, right? So this one is going to be, now you have to expand the bracket since it's negative 1. This is going to be minus 2k plus 7. Now u5 is going to be u4 plus 1 is going to be minus 1 to the whole power of 4. un is going to be basically u4, and plus k is going to be as it is. So 1, okay, it's positive, minus 2k plus 7, okay, plus k. And yeah, so one mistake I have made, there was plus k here, right? So this is going to be minus, sorry, I've omitted the k, okay, which was coming along. So this is basically going to be u4 is now going to be basically now 7 minus k. So here is going to be 7 minus k, the u4 over here. Sorry, my bad. Yeah, I just forgot the plus k that was attached to it. Yeah, now this one is going to be 7 minus k plus k. This and this cancels out. This is u5, u5, and u5 is going to be 7, and I've shown it. All right, given that the summation for r is 1 is equal to 30, find the value of k. All right, so now in order to determine the value of k, we don't know the sequence is arithmetic, geometric, so we cannot use any summation formula. So we basically now from u1 to u2 to u3 to u4 to u5 till u4, if we add these sequences, they said that you should get 30 for part B. Yeah, because that's normally what you do when you add the sequences, given that you don't know it's geometric, arithmetic, or whatever. Yeah, okay, so if I follow the u1, u2, u2, u3, u4, u4, and we know the u1s, u2, u3, and u4, so we just plug this all old information, u1, u1s, u2, u3, u4, okay, and set it equals to 30. So now u1 is 7 plus u2 we have found is k minus 7 plus u3 is plus 2k minus 7. All right, u4 is going to be plus 7 minus k is equal to 30. All right, 7 minus 7 minus 7 plus 7. All right, so 7 minus 7, okay, minus 7 plus 7 is 0, so they are cancelled out. Now we have k, 2k minus k, so 1 plus 2 minus 1 is going to be 2k. Okay, so let me just change it. This is going to be 2k. What's left? No, there's nothing left, so 2k is equal to 30, and 30 over 2, okay, is basically going to give us k is equal to 15. Hence that is our final answer. Now it asks us to find the value of 150 r is equal to 1. Okay, so now let's just put the k's into u1, u2, and ut, and let's see what pattern we are getting. Right, so this is going to be 7 plus k minus 7, so that's 15 minus 7. Okay, so let's just determine the pattern of the sequence. Okay, so this is 7, 15 minus 7 is 8, and for I'm just doing for u1, u2, and u3, and u4 till u5. all right, and for u3 we have 2 times k, which is 15, minus 7 is going to be 23, u4 is going to be 7 minus 15, which is going to be minus 8, and what's going to be u5? Now u5 is just going to be 7. So basically now the same mechanism is going to kick again when I do the next process, because since this sequence is periodic, right, it's repeating 7 hat come again. So sequence, so this means that sequence has an order of 4. They're asking we need sum till 150. So basically this will repeat until 150, right, till wait. So basically now over here what we can do, I can divide the how many terms in the sequence, divided by the order of the sequence, which is going to be 4. All right, now you can do kind of similar to long division method to find the remainder. All right, so 150, is it wholly divisible by 4? It's not wholly divisible by 4. So 4 times by, you can say, like, nearest to 150 would be, I guess, well, I guess that would be around like 30, I think so, around 4 times. Kind of, I'm not sure where it could be the nearest I can find is going to be 4 times 37 is 148, and we have two remainder. Now let me create some space here. Now we have 37 times by, how many order are there, since it's not fully divisible. Okay, so you will just multiply 37 times by this sum, 7 plus 8 plus 23 minus 8 plus first and 2. So this means that 2 means the first order and the second order. You have to add at the end how many remaining are the left, the sequence at the end, since it's not fully divisible, right? So this is going to be 7 and plus 8. So 37 times by 7 plus 8 plus 23 minus 8 plus 7 plus 8 is going to be 1125, and that's the final answer. Oh, and now here we go, we have a third question. F of x is equal to 2x cubed minus x squared plus ax plus b, where a and b are integers, given that when f of x is divided by x minus 3, the remainder is 55. Right, so that means, what this statement means is, when f, now basically x plus 3 is equal to 0 and x is minus 3. Now that means that when you sub in f of minus 3, the remainder you'll get, the answer you'll get, is going to be 55 into this equation over here. Alright, and we have to show that 3a minus b is equal to 180. So yeah, so basically now over here 55 is going to be, you have to sub in the minus 3 over here in place of x's, right? So 55 equal to 2 times by minus 3 cubed minus 3 squared plus a times minus 3 plus b. So 2 times minus 3 cubed minus 3 squared is going to be minus 63 minus 3a plus b. I'm going to take okay, this is 55, so let me take this to other side because we want 3a positive and minus plus b as negative. So this is going to be 3a minus b, and I'm going to do minus 55 on both sides. Now 63 minus 55 is just going to be 118, and we have shown this equation. Alright, now second bit of information out they are giving is that given that 2x plus 5 is a factor of f of x, find the value of a and b. So one thing is should be clear: whenever there are two variables involved, you have to do simultaneous equations. Now second bit of information now they are giving is when 2x5 is equal to 0, this is going to be 5 over 2, x is equal to 5 over 2. All right, now whenever I sub in f is equal to 5 over 2 into this equation in place of x's, sorry, I should get 0. Literally 0. So what you have to do here is just sub in 5 over 2. Okay, so when I substituting 5 over 2 cubed minus 5 over 2 squared plus a times by 5 over 2 plus b is going to be 0. Okay, let me just simplify this one. So this is going to be 25 plus 5 over 2a plus b is equal to 0. Now what I'm going to do is take minus 25 to the other side. We have 5 over 2a plus b. Right, now you have to solve them simultaneously. You can do either by substitution, okay, or by elimination. It's up to you. I'm not going to waste any time on this. All right, I'm just going to put this into my calculator. All right, so now a is going to be 20 minus 26 and b is going to be 40. That's the value of a and b. Hence find the value of quotient when the f of x is divided by x minus 7. Alright, so let me just copy down the equation over here. Basically now over here, when we have to use the polynomial division over here, 2x cubed minus x squared. Now since a is going to be minus 26x plus 40, now say right, now I have to do the division method, the long division. So I'm going to do is divide this term by this, all right, and write it over here, and then expand this term and write the term over here, right? So 22x cubed divided by x is just 2x. Expand the bracket, so we have 2x cubed, right? And 2 times minus 7 is going to be minus 14x. Yeah, this is going to be x squared, right? This is x squared, alright? Now this is going to cancel out. Now this is going to be minus 1 minus minus 14 is going to be 13x squared minus 2x plus 40 plus, now you do the same process. This is going to be 13x, right? Expanded, it's going to be 13x squared. 13 times by minus 7 is going to be minus 91x, and you kind of minus them out, so this is going to be 0, and this minus 26 minus minus 91 is going to be 65x plus 40. Now 65, okay, divided by x is just going to be 65. Expanded, we have 65x, and we have 65 times minus 7 is going to be minus 455. Now I'm going to minus this 65 cancel out. Now 40 minus minus 455 is going to be 495. So our value of quotient is going to be 2x cubed, 2x squared plus 13x plus 65. Summary over here. Now what I have done is divide this term by this, right? Draw that over here, expand the term with this and with this, right? And I write that down over here. Similarly, when I cancel them out, when I get this result, I use this term, the first term, divide by this first term, write it down over here, expand it, and yeah. And that's our question number 3 done. Okay, now find dy over dx. So we have curve has this equation, 4x to the power of r minus 9x to the power of r plus 3, right? So we have to find dy over dx. So dy over dx is going to be 4 times a half, right? Is going to be 2x and a half minus 1 is going to be a minus a half. 9 times a half minus a half is going to be minus 9 over 2. X is going to be minus half, minus 1 is going to be minus 3 over 2. Right, so now here's our dy over dx in the simplest form, right? Now that's our part A done. Now part B says that find the x coordinate of the stationary point. So whenever we are finding the stationary point, dy over dx should be set is equal to 0, alright? So that means that 2x to the power of minus half minus 9 over 2 x minus 3 over 2 should be equal to 0. And now we have to solve this equation. Bit tricky. It's a bit tricky. Now I can rewrite this as 2 to the power of x to the power of half minus 9 over 2 x to the power of 3 over 2 is equal to 0. Now, well, I guess what we can do here is we can take a common factor, right? So we can take a common factor of let's say 1 to the power of x to the power of half, Alright, and because when we are going to multiply, we are going to add them, right? So this is going to be 2, right, minus 9 over 2 x, right? Now 3 over 2 minus a half, sorry, is going to be just to the power of 1 is equal to 0. One thing is for sure is x is going to be 0. One of the points is going to be stationary point is going to be 0. Now what we can do, I can set this equal to 0 as well, and consequently I can bring this to here, cross multiply for x is equal to 9, and x is going to be 9 over 4, and hence that is going to be our one stationary point, the x coordinate. Alright, so just to summarize, in order to find the stationary point, set dy over dx is equal to 0. I have done that. Use the laws of indices to write this into the denominator, right? And since it's the power is negative, we can write this into the denominator. Now what I've done is using the laws of indices, you should notice that this half x to the power of half in the denominator can be factorized, right? Because when you times by 2, you're going to get 2 over x to the power of half, and whenever you multiply this by 9 over 2x, you are going to get 3 over 2, right? Because powers add, and here when I take factor of a half, a power is minus, right? So when I write in this into a bracket form, I set this one is going to be 0 and this one is set is equal to 0. I get 9 over 4, and that's our answer. Right, now the part CI says find the d squared y over dx squared. So basically now here we have to find the second order derivative, right? So this is going to be now basically like dy over dx, just one more time. So 2 times a half, we are going to get minus 1 and minus a half, minus 1 is going to give us, when you drop to the power of 1, minus 3 over 2, and minus 9 over 2 times by minus 3 over 2 is going to give us positive 27 over 4 minus 3 over 2 drop to the power of 1 is going to give us x to the power of 5 over 2, and that's our second order derivative. Right, so now in order to find the, hence determine the nature of the stationary point of C, giving reason for your answer, right? So if we need to find the stationary point, we have to sub in the x over here. Now we had previously found the x coordinate of stationary point, and just put this into your calculator. Right, so the answer I'm getting is 62 over 7. Now 16 over 27 is greater than 0. Hence, it is going to be local minima. Local minima or local minimum point. Find the values, range of values of x for which y is decreasing. Right? Now over here, if it is the minima, local minima, the shape of the graph will look U shape, something like this. If it was local maxima, it is going to look like this, but since in this case it is local minima, it is going to look something like this. All right, now state the range of values of x for which y is decreasing. So basically now over here, that means that we have to do, if it is decreasing, dy over dx should be less than 0. Now we have to solve this inequality since we already have the x values over here, which is going to be x is equal to 0, x is equal to 9 over 4. When you draw a rough sketch, let me just zoom in over here. When you draw a rough sketch of graph, this is going to be 9 and this is 9 over 4 here. The shape of the graph looks something like this. Now if it is decreasing, it is going to be less than 0, right? Let me just mark it very clearly with different color pen. And 9 over 4, and when I draw, the graph looks something like this. Now since it is less than 0, we are going to be somewhere over here, below the line. Less than 0 means below the line. So if it is the below the line, that means we are looking for the x values between here and here. So that means that our final answer is going to be 0 is going to be greater than x, and 9 over 4 is going to be less because it's towards the right. And this is going to be our final answer. Find in terms of a the first three terms in ascending power of x, the binomial expansion of 2 plus ax bracket to the power of 6, right? So this is going to be 2 to the power of 6. This is going to be, the n is going to be 6, r is going to be 1, a is going to be 2, 6 minus 1, right? And this is going to be ax to the power of 1. Our second term, 6, 2, 2, 6 to the power of minus 2, and ax whole to the power of 2. Now first three terms, right, is going to be 64. Now you have to go to the NCR button into your calculator over here. So shift, and there's going to be NCR button, you click there. So you type 6, all right, there's something like C. Okay, when you click CR, shift CR, so you write 6 before here and 1 over here, and times by 2, 6 to the power of minus 1. Okay, plus 102 ax plus 6 say 2 times by 2 to the power of 6 minus 2 is going to be plus 240 a squared and x squared, right? So that's A part done. Now B part. Given that the constant term in the expansion of f of x is 576, find the value of a. Well, first thing is first, let's just expand this. All right, this is right, so this is going to be 3 over 1 over x, 3 plus 1 over x. All right, so this is going to be 9 plus this is going to be 3 over x plus this is going to be 3 over x. This is going to be 1 over x squared. This is going to be 6 because denominator is same. You can add the numerator. This is going to be 1 over x squared. Now whenever they say the constant term in the expansion, that means that they are looking for a term that doesn't have a x. All right, a term independent, you can say, of x. And how we can do that? Well, you just write like this, right? The bracket, and this, the binomial of expanded version is going to 64 plus 192ax plus 240 a squared and x squared. All right, now, all right, so what we need to do here, we can find terms that is independent of x by multiplying 9 times 64, right? So 9 times 64 is going to be 576. Great. Now we can do 6x times 198 because whenever you expand them, 192ax, right, times by 6x, the x's are going to cancel out, right? And similarly over here, whenever you expand 1 over x squared with 240 a squared and x squared, the x squared will also cancel. So 192 times by 6 is going to be plus 1152a plus 240 a squared, right? When I expand this, when I multiply, right, and that is equal to 576. Now 576 can cancel out, so we are left with 240 a squared plus 1552a is equal to 0. So now over here, what we can do, we can factorize the a. We have 240 a plus 1152a, oh, not a, just 1152 is equal to 0. Now this is a quadratic, so that means that a is going to be 0, and 240a plus 1152 is equal to 0. 152 divided by 240, a is going to be the answer. So this is going to be 1152 over 240 is going to give us minus 24 over 5, and that is our final answer. Okay, let's just move on. Using the laws of logarithm, solve log to the base of 4 bracket 12 minus 2x is equal to 2 plus 2 times log to the base of 4 bracket x plus 1. Alright, so now first the target of this logarithm we have to write in a single logarithm. Yeah, log am is equal to x, right? So we have to write log an is equal to x, which can be rewritten as ax to the power n, and that's our target. Right, this is the first target that we have to write into single logarithm, and here we have something like number. Alright, so first step I'm going to do now is I will replace 2 plus this 2 over here, right, this 2 over here with oops, with log 4x plus 1 to the power of 2, because this is a power rule, right? So whenever if anything is written outside, I can write this as to the power of 2, right? So this is a law of logarithm that I'm applying over here. Now since I have to write into a single logarithm and there should be some number, some constant, some integer or whatever, in order to write to exponential form, I'm going to do log 4 12 minus 2x minus log 4 x plus 1 squared is equal to 2. Now the laws of logarithm says that whenever the logs are subtracted, we apply the division rule. All right? So I'm going to write this as this by applying the division rule is equal to 2. All right, this is the important step over here. So basically now we have to write this as into exponential form. A is the base. All right, A is the base, x is the power, and this is the answer. Now in case of a logarithm, the base, let me show, the base is this one, the A, 2 is the power, and this one is the answer. So now 4 to the power of 2 is equal to 12 minus 2x x plus 1 squared. Now 4 squared is just 16 times by, I just multiply on both side by x1 plus 1 bracket square is going to be 12 minus 2x. 16 times by, x plus 1, 12 minus 2x, right? 16, this is going to be x squared, this is going to be plus x plus 1, 12 minus 2x, this is going to be x squared plus 2x plus 1 is equal to 12 minus 2x. This is going to be 16x squared. 16 times 2 is going to be plus 32x plus 16 is equal to 12 minus 2x, right? Plus 2x on both sides minus 12x on 12 on both sides plus 2x minus 2x. This is going to be 0 since it's going to be quadratic. So 16x squared, 32 plus 2 is going to be plus 34x, and 16 minus 12 is going to give us plus 4. Right, now let's just put this into our calculator. Let's see what you have. Right, so we have 8x plus 1, and I factorize an x plus 2. So that means that x is going to be minus 108 and x is going to be minus 2. This is an important, very important step, because in this steps many people make mistakes. So now over here the question says, now you have to basically 12 minus 2x and we have x plus 1. Substitute this x values over here. Let's see what we have. All right, So 12 minus 2 times by negative 108, I get positive answer. Alright, minus 108 plus 1 is going to give us 708, which is again positive. When I apply for x is equal to minus 2, so 12 times my 2 times my minus 2, alright, I'm getting still a positive answer, and minus 2 plus 1 is negative. So the laws of, now basically logarithms, a very important rule is logarithms never be negative. Never be negative. Never ever be negative. So we have to reject, okay, we have to reject x plus 2. Hence x is equal to minus 1 over 8 is going to be our